Welcome to Kundan's tutorial. Today we will see the topic diazotization titration or nitrate titration. This is a type of non-aqueous titration in which we do not use aqueous solution or any aqueous water molecules. In this titration, when sodium nitrate and HCl reacts, then they will produce nitrate HONO and NaCl.
Hmm.
This mainly reacts with aromatic primary amine.
Hmm.
It never reacts with any aliphatic primary amine because the salt formed with aliphatic amine will again degrade it because that one is highly unstable, and this salt is quite stable but at low temperature about 10 to 15 degrees Celsius,
Hmm.
and along with it will produce water molecule. So in this titration we will detect the amines group present in an aromatic compound. So this reaction, in this reaction we will take NaNO2 in burette. This is the burette which contains
NO2.
NaNO2, and again we will also take a conical flask. This is the conical flask, and this conical flask contains the aromatic amine plus acid. Okay,
Hmm.
so aromatic amines and this HCl. In this solution, an external indicator, external indicator is used. Internal indicator and external, there are two types of indicator, internal and external. Internal indicators, those indicators which involve in the reaction medium during the titration. Suppose I have put phenolphthalein in this solution, then that one is called internal indicator. But external indicator, we will titrate this solution. After then we will put a little amount of this solution upon a paper to detect whether the compound is titrated or neutralized or not. So here we will take external indicator as starch paper. Okay, and during the preparation of this solution starch paper, we will add some iodine molecules, I2. Okay, I2, and this I2 is directly not involved in the reaction. At the place of I2 we will take K, potassium iodide.
Hmm.
This potassium iodide added in the solution. So this potassium iodide Ki reacts with HCl, acid present in this medium, to give rise Hi, hydrogen iodide plus potassium chloride. This Hi ion again reacts with this, so this compound to HONO, okay, excess, to produce I2 and NO plus H2O. So what happens here, we will add Ki along with this solution. In diazotization reaction, this NaNO2 reacts with HCl to produce HONO. as much HONO produced, this HONO reacts with primary amine. So all primary amine will be neutralized by HONO up to certain extent, as much this primary amine will be produced. At the end point, this NH3 amine group, aromatic amine, at the end point neutralizes. There is no presence of primary amine because all primary amines are converted into N2Cl, diazonium salt. So there will be excess of HONO. This excess of HONO present in that solution after the end point will react with this potassium iodide, a hydrogen iodide solution to give the end point. That means only at end point we will get the HONO access, because that one is not participating in this reaction, and this HONO access HONO reacts with HI to produce iodine. Again, when we will take some amount of this solution upon starch paper, so this starch paper will retain the iodine and give a blue color, and in this way we can detect the end point in a diazotitration reaction. As in this case we have taken nitrate ion, so it is also known as nitrate titration. And next point we will see about the condition for the diazotitration. Condition for diazotization. Condition for diazotization. So diazotization mainly depends. Diazotization is mainly affected by two factors. One, rate of titration, and another one is temperature. So rate of titration, as we know that this is not, the salt produced during this reaction is not very stable. So, and as we add this NaNO2 in this conical flask, it takes some time to react with this primary amine, because at first this will undergoes reaction with HCl. Okay, after the formation of HONO, this will react with the primary amine to produce the diazonium salt. So rate of titration, this is called rate of titration. So rate of titration can be increased or decreased by the presence of some specific group at ortho and para position of benzene ring. As we know, suppose number one, rate of titration. So there are two types of compound present. One is ring activating compounds and ring deactivating compound. Benzene is mainly concentrated with the electrons, when another group attached to it which has tendency to pull its electron from benzene ring, that will deactivate its activity, and if its activity will decreases, then rate of reaction will be ultimately decreases. And some reagents which pulls the electron inside this ring, so ultimately the electron density of this ring will increase. If the electron density of this ring will increase, then rate of reaction will increase, because in this reaction into Cl, this is a electrophile. Electrophile, that means electron loving group. When electron density increases in this ring, then electron loving group has more tendency to attack here. So there are two types of group, as I have earlier mentioned, a ring activating and ring deactivating. So ring activating groups ring activating groups ring activating groups increases the electron density. Example, CH3, OH hydroxyl and etc. These will push the electron inside the ring, and the activity of this ring will increase and rate of titration will increase. And another one is ring, second point is ring deactivating groups. Ring deactivating groups. So ring deactivating groups are those groups which pulls electron from this ring. Suppose SO2, okay, NO2, example, SO2, SO2, NO2, etc. These will attracts the electron towards themselves, and that leads to deactivation of this ring towards the electrophilic reaction into Cl, and the rate of reaction will fall. Rate of reaction will fall. Okay. So 2 points. Rate of titration. Under the rate of titration, we have seen the two groups mainly which affect the rate of titration: ring activating group and ring deactivating group. So ring activating group will increase the rate of titration, and ring deactivating group will decrease the titration. And second point is temperature. Temperature. So temperature is a key factor in this reaction, because the salt's diazonium is stable only at low temperature. At low temperature, 0 to 5 degrees the proper temperature. Low temperature for the stability. For the stability of diazonium salts. Okay. So again, in the titration, at last we detect the end point. To end point determination, so end point can be determined by two methods. The first one is visual end point, visual end point, and second one is electrochemical end point. So visual end point and electrochemical end. Visual end point, we have already known about this. Starch paper, we will take a starch paper, and the excess of iodine which is produced due to nitrate ions, the excess of iodine will react with starch paper to give blue color. This is visual because we can easily visualize this. There is change in color, as normally all the titration are visual from the acid base titration, like phenolphthalein will change its color. And second one, which I will explain here, is electrochemical endpoint. In the electrochemical endpoint, uh, we will set up an equipment. This is the conical flask. In this, we will put one electrode with the platinum, and a battery is fixed here, and at the battery there will be a galvanometer, plus minus, this one is galvanometer. At first there will be neutralization reaction initially, no concentration of acid, excess concentration of acid, because that all participated in reaction, so no current will flow and galvanometer doesn't show any deflection. But at the end of this reaction, there will be excess of HCl, liberates excess of nitrous acid, HONO. At the end point, because HONO is not participating in formation of diazonium salt, so this excess of HONO, nitrous acid, will depolarize this platinum plate, PT plate, and this depolarization leads to flow of current, which shows deflection in galvanometer. Deflection in galvanometer. And through electrochemical endpoint, we got a sharp endpoint which is more accurate than starch paper, because at the some interval we should have to put some solution from this conical flask and pour it upon the starch paper, but we can't exactly measure the exact value where the endpoints we get. But at electrochemical endpoint, we will get a sharp endpoint, and this sharp endpoint this sharp endpoint is called as dead stop endpoint. Dead stop endpoint. This is called dead stop endpoint. So last thing, what's the application of diazotization? What's the application of diazotization? So diazotization is mainly applied in pharmaceutical industry to detect the presence of primary amine group present in a chemical compound. So to detect the primary amino group present in drugs, the main utility of this titration to detect the sulfur containing drugs, all the sulfamides, benzoyne, or etc., which contains sulfur are mainly detected from this method to detect the primary amino groups present in drugs, and it mainly used in assay of all sulfur drugs. Okay, thanks for watching.